Hello, geometry students. Today we're going to be going over the Unit 3 activity. So hopefully you already did the workbook, the rest of the workbook besides the activity. But if not, no big deal. Hopefully I'll have a video for the workbook soon and you can do that or do it on your own. And but today, right now, is just for this video is just the activity. Okay, so go ahead and open up your workbook to the activity. And just a reminder, whatever I write, you should be writing. So go ahead and open up your workbook, and we're going to go to the, it's called the performance task in this case. And I forget which page it's on, but let's just scroll through and we'll eventually find it. I know it's towards the end of it. Okay, so here we go. Basically, here's the assignment here. Now, this is on page 28. It says, use the space below to answer questions 1 and 2. In the diagram below, AC is parallel to DF, which is also parallel to BH. So let's take a look at what they're talking about here first. So it says AC, so that's right here, is parallel to DF, which is right here, which is also parallel to BH, which is right here. So basically these three lines that I drawn in blue, these three lines are all parallel to each other. Okay. Then it says CB is parallel to FE. So I'm going to go and highlight those. CB let me highlight. Okay. Let me erase this. So CB, so that's right here, is parallel to FE. Okay. So we have 3 parallel lines going this way, and then 2 parallel lines going this way. All right. Now let's take a look at our first question. It says, find 4 similar triangles. Explain how you know that they are all similar. Okay, so hopefully in this picture, you'll be able to see there's 4 triangles in the picture. There's one right here, A, B, C. So this triangle right here. There's a second triangle. I'm doing green. DGB, so a smaller triangle right here. There's triangle DFE or DEF right here. And then one more. There's this triangle right here, BEH. Now, according to this problem, all 4 of these triangles are all going to be similar to each other, meaning that they're all have the same shape, but just different sizes. Okay, so how are we going to show that they're all similar to each other? Well, we're going to have to use the information from the picture, but also the information from these fact that these are parallel to each other, and then the fact that these are parallel to each other. So let's go ahead and take a look at what we can get from that. So first thing I want to look at is I'm going to just draw this line down here. So here to the side, I'm just going to draw a little picture, and imagine this end is A and this end is E. Okay. All right. This is a smaller version, but I'm only showing you the parts that I want to talk about at this moment. So there's 3 parallel lines. So this would be like where C is. So that's like AC. Then there's another parallel line where F is at the top, and this D right here. And then there's one more parallel line, and that's B to H. Okay. So this ain't the best picture, but hopefully you can see that I'm talking about this bottom line here ADBE, ADBE, and then there's 3 parallel lines AC, DF, and BH. Okay, it's a B here. Okay, now what I want you to notice is that there are congruent angles within this picture. And hopefully you'll be able to see that the congruent angles are right here, and right here. So these 3 angles are all congruent to each other. In the big picture, that would be right here, and right here. So these 3 angles are the same as these 3 angles here. They're congruent to each other. Now, how do we know that they're congruent to each other? They certainly look congruent, right? They look like they're the same measure as each other. But we know they're congruent because of this information right here, that AC is parallel to DF, which is also parallel to BH. So what's the relationship between these angles? Well, if you remember from Unit 2, these are what we'd call corresponding angles. So the first piece of information we're going to write is that angle. Now, here, this is angle A, which is going to be congruent to angle. Now, what would I name this one right here? Would I just say angle D? Well, that's a little tricky because there's actually 2 angle Ds, right? There's this one in red, but there's also like this one that I put in blue here. So these are 2 different angle Ds. So if I just put angle D, it's not clear which one I'm talking about. So how do I make it clear that I'm talking about this red one here? Well, we can call it angle BDG, and then that clearly shows that I'm talking about this angle. So angle BDG. So just make sure whenever you're writing an angle with the 3-letter notation, make sure the vertex of that angle is the middle one, right? So you could see BDG. Right. Could I have said that over here? Yeah, I could have said angle DAC. That also would be this angle. But when I say angle A, you know which angle I'm talking about. Angle D, it's not as clear because there's 2 angle Ds. But there's really only 1 angle A, so I could just say angle A, which is also congruent to this angle here. So what would this angle be? Angle EBH. Okay, angle E. B is the vertex. H. Okay. And how do we know that's true? Well, because of corresponding angles. Because of corresponding angles. So I hope that at least sort of makes sense, that these angles correspond to each other because of these parallel lines cut by the transversal AE. Okay, I'm going to erase this here, but we're going to use that same idea to help us find some more congruent angles. So we use this first piece of information. We use the information that AC is parallel to DF, which is also parallel to BH. But now I want to use the information that CB is parallel to FE. So again, we have the line on the bottom. So this I'm going to say is like AE. But then I'm going to show these 2 lines, CB and FE. So CB, this, and FE goes a little bit longer, but these 2 are parallel to each other. So CB and FE. Okay, so do you see the corresponding angles in this case? Well, hopefully you would be able to see that angle B right here, or angle ABC, is congruent to angle BEF. And the reason why? Again, corresponding angles. Okay. Notice for these ones I did a double swoosh, a double little thing. I don't want to do a single because I used a single swoosh for these. If I did a single swoosh for these ones as well, I would be saying all the angles are congruent. So I want to say that this angle and this angle are congruent, but not congruent to these. Okay, hope that sort of makes sense why I differentiated the number of swooshes there. Okay. So here we would say angle. Now, what would I name this angle right here, where I put the swooshes next to B? Can I just say angle B? Well, no, there's looks like there's 3 different angle B's, right? So how would I show that I'm making sure I'm talking about this angle specifically? I could say angle DBG, right? Or angle GBD. That's also correct. So angle D, B is the vertex, and G, okay, which is congruent to this angle here. Now this one I could just say angle E because there's just one angle E. There's only one angle there. But if you said BEH or BEF, that would also be correct. And again, it's because of corresponding angles. So make sure you finish the sentence here, because of corresponding angles, just like how we did here. Okay, so I'm gonna put dot, 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 but you'll go ahead and complete that in words, because of corresponding angles. So now what do we have? We have our 4 triangles, which I showed you before. And we have all these congruent angles to each other, right? So now what? Now I can say that these triangles are all similar to each other. So the way we'd show that is, again, this first triangle, ABC, triangle, ABC is similar to, so for similar, it's just a squiggle, triangle. Now, what would this small triangle be called? So if I said ABC for this one, notice I'm starting on the left, then going right, then going up. ABC. I want to make sure I'm going in that same order for these other triangles. Make sure the corresponding angles, that I'm saying them correctly, right? So for this one, it would be DBG. Notice I'm going in the same order, right? So I went from like the left part to the right, then up. Same I want to do here, DBG. Okay, it's triangle DBG. You want to make sure that you're correctly putting which angles correspond to which ones. Okay, which is also similar to, what would I name this triangle on the right? This triangle right here. What would I call that? Well, that would be triangle BEH. Hope you can see that. BEH, which is also similar to triangle. And lastly, it's the big triangle here. So what would the name of this big triangle be? Again, I want to go left, then right, then up. So that'd be DEF. DEF. Okay. Now, how do we know that's true? How do we know that all these triangles are similar to each other? So comma, because why? Well, it has to do with all those angles that are congruent to each other. Okay. Notice for this triangle, ABC, you have one angle with a single swoosh and then one angle with a double swoosh. Okay. Is that the same with this triangle over here, BEH? Well, yes, it's the same. One with a single swoosh and one with a double swoosh. Is that the same with this triangle here, the smallest one? Well, yes, there's one angle with the single swoosh and one angle with the double swoosh, right? Is that the same for the biggest triangle? Hopefully you can see yes. For the biggest triangle, DEF, that you have one angle with a single swoosh, angle D, and then one with the double, angle E. So every single one of these triangles has one angle with the single swoosh, those are all congruent to each other, and then one angle with a double swoosh, and those are congruent to each other. So when you have two triangles where 2 of their angles match each other, then we could say those triangles are similar because of, and this goes back to earlier in the unit, the triangle similarity postulates. So this one's because of angle similarity. So we just write AA squiggle, and that means angle similarity. So we know that all these triangles are similar to each other because of their matching angles, which the property is called angle similarity. All right, and that's that. Okay, so now we've shown how we know that all those triangles are similar to each other. Okay, question 2. Using the similar triangles you found in part 1, complete the following extended proportion. So here it says AB over AC. So one of the things we want to keep in mind is that when you have similar triangles, the sides are proportional to each other. Okay, so here they're saying AB over AC. So that's looking at this triangle here, the far left one. So AB is this bottom length, and AC is this length here. Okay, so they did the bottom length over this length. AB over AC. So AB over AC. This proportion will be the same as, well, let's look at from this smallest triangle here. So instead of an AB here, this would be DB, right? DB over, and instead of AC, what's in that position? DG. Okay, DG. Okay, and that should equal the same proportion as for this. Let's look at this rightmost triangle here. Well, that would be BE over BH, the bottom over the one going up and right. Lastly, let's look at the biggest triangle here. So this would be DE over DF. DE over DF. Okay. So we want to make sure that we're putting all these correct. So for this one, AB over AC. The next one says DE. So what should this one be here? So ours was DE over DF. Okay, so this one should be DF here. This next one has DG in the bottom. So that should be DB on top. And this one's the blank one. This is the one we haven't used yet, which would be this BE, BH. BE over BH. Okay. And that's it. Okay. I hope that that made sense. Stop presenting here. Hope that made sense. And if you have any questions, you could always put them in the Google Classroom, and I will see you guys next time.